Hello everyone, welcome to this new session. So in the last session we had started with the type 1 non-homogeneous differential equation problems. So we'll continue with the problems, okay. So the first question for this session is d power 4 minus 18d square plus 81y is equal to 36 into e power 3x. So here the value of e power ax, e power ax, right? The value of a here is 3, okay. Yeah, to find the particular integral we need to put the value of a as 3, and we have given the f of d. F of d is given as d power 4 minus 18d square plus 81, okay. Yeah, so the first method remains the same. First we need to find the complementary function, replace d by m, that is m power 4. The cube term is missing. First I'll write that 0m cube minus 18m square, again the m term is missing, plus 0m plus 81 equal to 0. So here again we need to apply the synthetic division twice, write the coefficients 1, 0, minus 18, 0, 81, and we need to find the first root. So I've written the equation in the calculator, whatever is the f of d. Press the calc button and one by one put the values of x. When you put the value of x as 0, we won't get it. 1, we won't get it. Minus 1, we won't get it. 2, we won't get it. Minus 2, we won't get it. 3, yeah, see, for 3 we are getting the value of this as 0, okay. So we need to be very careful by checking. So we need to check the roots very carefully in the calculator, okay. So bring this 1 down, so 3 1s are 3, 0 plus 3 is 3, 3 3s are 9, minus 18 plus 9 is equal to minus 9, 3 into minus 9, that is 27, 0 plus 27 is 27, 3 into minus 9 is minus 27, right? Yeah, minus 20, 0 minus 27 is minus 27, and minus 27 into 3 is equal to minus 81. See, we got the answer as 0. So now write the cubic polynomial m cube plus 3m square minus 9m plus 27 equal to 0. Again apply the synthetic division only. Write the coefficients 1, 3, minus 9, 27. So now again put this equation in the calculator. Yeah, I've written this equation in the calculator. Press the calc and check for the x. What is the first root? It's not 0. We check for plus 1 first. No. Minus 1. No. 2. No. Minus 2. No. 3. No. Minus 3. No. See, here we made a mistake. So we need to be very careful. I'm sorry, I made a mistake here. So here in the calculator I have put plus 27. It should be minus 27, okay. Yeah. So now let's check the roots. Press the calc. 0, 1, minus 1, 2, minus 2, 3. Yeah, see, for 3 we are getting it as 0. So please be careful by solving, okay. Mistakes might happen, okay. 3 1s are 3, 3 plus 3 is 6, 3 6s are 18, minus 9 plus 18 is plus 9, 3 9s are 27. So this is 0. So we get m square plus 6m plus 9 equal to 0. So now for this apply the quadratic formula. So now let's apply. The value of b is 6, so minus 6 plus or minus square root of 6 square is 36 minus 4 into 1 into 9, again it's 36 divided by 2. M is equal to minus 6 plus or minus 36 minus 36 is 0. M is minus 6 by 2 comma minus 6 by 2, it's repeating twice since it is plus or minus 0. 2 1s are 2 3s are, so M is equal to minus 3 comma minus 3. So the total roots which we are getting here, I'll write it here, 3 comma 3 comma minus 3 comma minus 3. So here 3 3 minus 3 minus 3 are repeating, so the particular integral would be c1 plus c2x. For plus 3 it is e power 3x, and for minus 3 c3 plus c4x e power minus 3x. Okay, so this is your particular integral. So now so this is your complementary function. So now we'll solve for the particular integral. So this is the formula for particular integral. Okay, so here the value of a is 3, right? So here replace d by a. So y of p would be 36 e power 3x divided by 3 power 4 minus 18 into 3 square plus 81. So yp will be 36 into e power 3x divided by 3 power 4. 3 cube is 27, right? So 27 into 3 is 81. So 81 minus 18 into 3 square is 9 plus 81. So y of p would be 36 e power 3x divided by 81 plus 81 is 162. 81 plus 81 is 162, and 18 nines are again it is 162. So again now here we are getting 36 e power 3x divided by 0, right? So whenever it is 0, we know that we need to find f dash of d, right? F dash of d, f of d given is d4 minus 18d square plus 81. So its derivative of d power 4 is 4d cube, right? Minus the derivative of 18d square means 18 into 2, 36 into d, and the derivative of 81 is 0. So now for this we need to find the y of p. 36 into, whenever we took the f dash of d, we need to multiply the numerator by x into e power 3x divided by f dash of d here is now 4d cube minus 36d. Now for this the value of a is 3, right? But after replacing d by a, we get 36x e power 3x divided by 4 into 3 cube minus 36 into 3. So yp is equal to 36x e power 3x divided by 4 into 3 cube is 27 minus 36 into 3. Yp is equal to 36x e power 3x divided by 27 4s are 108 minus again 36 3s are is 108. Again we get the denominator as 0. So now if we get again the denominator as 0, we need to take the derivative of f dash of d again, that is f double dash of d. What is f dash of d? We got 4d cube minus 36d, right? Now again we need to take the derivative of this 4d cube, 4 into 3, 12, and 1d cube would be replaced by d square, minus the derivative of 36d is 36. Okay, so now again y of p would be 36 into, now x was there in the numerator, right? So we took another derivative, so it will be now x square, right, into e power 3x divided by 12d square minus 36. So here the value of a is equal to 3 again. So yp is equal to 36x square e power 3x divided by 12 into 3 square minus 36. So yp is equal to 36x square e power 3x divided by 12 into 9. 12 into 3 square is 9, right? 12 nines are 108 minus 36. So y of p would be 36x square e power 3x divided by 108 minus 36, that is equal to 72. So now we can cancel this, 36 1s are and 36 2s are. So finally we get the value of y of p as x square e power 3x divided by 2. So in this way we need to solve for y of p. See, please check all the steps correctly. So now final step is we need to add yc and yp. Now the general solution would be looking like y is equal to what yc we have got c1 plus c2x into e to the power 3x plus c3 plus c3 plus c4x into e to the power minus 3x. This is your yc plus what we have got yp x square into e power 3x by 2. So this is your required general solution for this problem. Okay, so we'll solve few more problems. So this is your next question. It's a very important question. D square y by dx square minus 4y into cos hyperbolic of 2x minus 1 plus 3x. So here in the r of x value we can see that there are two functions. So again we need to split into a particular integral as yp1 and yp2. Then in order to find yp we need to add them. Okay, and here yc remains the same. So first step is replace these. It is d square y minus 4y is equal to cos h 2x minus 1 plus 3x. So this is d square minus 4 into y. So replace d by m. It is m square minus 4 equal to 0. Okay, so this is now we can bring the we can directly do it without using quadratic formula. That is, bring this 4 to another side. M square is equal to 4. M is equal to plus or minus root 4. M is equal to plus or minus 2. Okay, so here the roots which we are getting is plus 2 and minus 2. So the particular integral can be written as c1 e to the power 2x plus c2 e to the power minus 2x. Okay, so this is your this is your complementary function. Okay, yeah, so I would be confused always. So now we will find the particular integral. So the formula for particular integral is f of d is given as d square minus 4 into r of x is cos of h 2x minus 1 plus 3 power x. So now we need to split these two terms, right? For that yp should be equal to yp1 plus yp2. Now we need to first find yp1. It is 1 by d square minus 4 into cos h 2x minus 1. Right? We know that this hyperbolic function can be written as, this is cos, right? So cos is e to the power 2x minus 1 plus e to the power minus of 2x minus 1 divided by 2, right? So this is e to the power 2x minus 1 plus e to the power, multiply this minus sign, so minus 2x and plus 1 divided by 2. So now we are going to replace this by this term. So yp1 is equal to e to the power 2x minus 1 plus e to the power minus 2x plus 1 by 2 into d square minus 4. So I have written this 2 along with this d square minus 4. Okay, so now for this we need to see the value of e to the power ax. So this is of the form, in the note we have written e to the power ax plus b. For that, this is of that kind, right? Yeah, so here also the same thing, we need to check the coefficient of a only. We should not check for b and all. So here the coefficient of a is 2, right? So we need to check the coefficient of a here. So before that we can split this term as e to the power 2x minus 1 divided by 2d square minus 8. I have just multiplied 2 to this term plus e to the power minus 2x plus 1 divided by 2d square minus 8. So for this the value of a is 2 and for this term the value of a is minus 2. So now yp1 would be looking like e to the power 2x minus 1 divided by 2 into 2 square minus 8 plus e to the power minus 2x plus 1 divided by 2 into minus 2 whole square minus 8. So yp1 would be looking like e to the power 2x minus 1 divided by 2 square is 4, right? So 2 4s are 8, 8 minus 8 is 0 plus e to the power minus 2x plus 1 divided by minus 2 the whole square. Again it is 4 and 2 4s are 8, 8 minus 8 is 0. So here we can see that in both the cases the value of f of d is 0. For that now we need to take the derivative of f of d, that is f dash of d. What is f of d given? D square minus 4, right? So now the derivative of d square is 2d and 4 is 0. So the value of f of d is 2d now. So now we are going to substitute that f dash of d. So now yp would be looking like, since we have taken the derivative, we need to multiply x in the numerator. So x e power 2x minus 1 divided by 2 into 2d. We had here 2 right in the denominator, plus again multiply x e to the power minus 2x plus 1 divided by 2 into 2d. Okay. So now here again x e power 2x minus 1 divided by the value of a here is 2, right? 2 divided by 2 into 2, so 4 x e to the power minus 2x plus 1 divided by 2 into 2 into minus 2, right? So this is minus 8. So x e power 2x minus 1 divided by 8 minus of x e power minus 2x plus 1 divided by 8. So this is your required y of p. Okay. So now we found yp1 here. Okay. This is not y of p, this is yp1. So now we are going to find yp2. 1 by f of d remains the same, d square minus 4 into the r of x is now 3 power x. So you know that whenever there is 3 power x, it can be replaced by e power log 3 into x divided by d square minus 4. So here the value of a is equal to log 3, right? So we don't need to simplify this by putting the value of log 3 in the calculator and all. We can keep the value as it is, okay? Don't need to simplify. So e power log 3 of x is equal to log 3 whole square, d squared minus 4. So this itself is your yp2. Okay. So the final yp would be looking like yp1 plus yp2. So x e power 2x minus 1 minus x e power minus 2x plus 1 by 8 plus e to the power log 3 of x divided by log 3 whole square minus 4. So this is your y of p. So now we are going to write the general solution, final general solution. Y is equal to yc plus yp. So therefore y which we get here is, what is the complementary function we got? c1 e to the power 2x plus c2 e to the power minus 2x plus the particular integral is x e to the power 2x minus 1 minus x e to the power minus 2x plus 1 by 8 plus e to the power log 3 of x log 3 whole square minus 4. So this is your final particular solution, general solution. Yeah, so we have one more problem. We'll solve that, then we'll wind up this session. So this is the last question of your session. dq plus 3d square plus 3d plus 1 of y into 5 e power 2x plus 6 e power minus x plus 7. So here also the r of x is split into 3 terms. So we need to find yp1, yp2 and yp3. Then we need to sum this up to find yp. Okay. Yeah, so now we'll solve for yc first. The same thing, put d is equal to m. Then would be m cube plus 3m square plus 3m plus 1 is equal to 0. So now this is a cubic polynomial, so we need to find the roots by synthetic division. Write the coefficients 1, 3, 3, 1, and we need to write the equation in the calculator. I've written it in the calculator. Now press calc, check the first row. 1, no, minus 1, yeah, for minus 1 we are getting the value of this equation as 0. So the first root here is minus 1. So bring this 1 down. Minus 1 into 1 is minus 1. 3 minus 1 2. Minus 1 into 2 is minus 2. 3 minus 2 1. Minus 1 into 1 is again minus 1. So this is 0. So the quadratic polynomial you are getting is m square plus 2m plus 1 is equal to 0. So now let's apply the quadratic formula for this one. Value of b is 2, so minus 2 plus or minus square root of 2 square is 4 minus 4 into 1 into 1, so that is 4 again divided by 2. So that's equal to minus 2 plus or minus 0, right, by 2. So m is repeated minus 2 by 2 comma minus 2 by 2, that's equal to 1. So the m is minus 1 comma minus 1. So we got two distinct roots. So the total roots we got here is another one minus 1 is there because the first minus 1 is the root, right? So we have 3 repeated roots. So the complementary function would be written as c1 plus c2x plus c3x square, because 3 times it's repeating, right, into the given root, that is e to the power minus x. So yeah, this is your complementary function. So now we'll find the particular integral. 1 by f of d is given as d cube plus 3d square plus 3d plus 1 into r of x is 5 e power 2x plus 6 e power minus x plus 7. So now one by one we'll take 1 terms and we'll first find yp1, that is 5 e power 2x divided by the value of a here is 2, right? So now this would be 2 cube plus 3 into 2 square plus 3 into 2 plus 1, that is equal to 5 e power 2x divided by 2 cube is 8 plus 3 into 2 square is 4, 3 4s are 12 plus 3 2s are 6 plus 1. So therefore yp1 is equal to 5 e power 2x divided by 12 plus 8 is 20 plus 6 plus 1 7, so it is 27. So we found for yp1. Now the same way we are going to find yp2, that is 6 e power minus x divided by d cube plus 3d square plus 3d plus 1. Here the value of a is minus 1. 6 e power minus x into minus 1 whole cube plus 3 into minus 1 square plus 3 into minus 1 plus 1, that is 6 e power minus x divided by minus 1 whole cube, that is minus 1 only. 3 into minus 1 square is plus 1, so plus 3 minus 3 plus 1, so minus 1 plus 1 cancels, minus 3 plus 3 cancels, so 6 e power minus x by 0. So now we have 6 e power minus x by 0, so the denominator is 0, we need to take its derivative now. So now f dash of d, the given f of d is d cube plus 3d square plus 3d plus 1, right? So its derivative of d cube is 3d square plus 3 to the 6d plus 3. So this is the derivative. Now the equation of yp2 would be looking like 6, we have taken the derivative, so 6x into e power minus x divided by 3d square plus 6d plus 3. So here the value of a is minus 1 only, so now 6x into e power minus x divided by 3 into minus 1 square plus 6 into minus 1 plus 3. So yp2 is equal to 6x into e power minus x divided by minus 1 square is plus 1, so 3 1s are 3, 6 plus 3, so 3 plus 3 is 6 and 6 minus 6 is 0. Again we got yp2 is equal to 6x e power minus x by 0. So we got 0, so again we need to take its derivative of f double dash of d. So the given f dash of d is 3d square plus 6d plus 3. So when we take its derivative we get 3 to the 6 right here, so 6d plus the derivative of 6d is 6. So now the yp2 would be looking like 6 into, so we had x in the numerator now, so we took another time we took the derivative, so now it will be x square e power minus x divided by 6d plus 6. So yp2 is equal to 6x square e power minus x. So here the value of a again is minus 1. So 6 into minus 1 plus 6. Again yp2 is equal to 6x square e power minus x divided by, again we would get 0. See, minus 6. 6 into 1 is minus 6 and minus 6 plus 6 is 0. See, again we got 0. So again we need to take the derivative. Till we get zeros, right, we need to take the derivative. So now it is f triple dash of d. So f double dash of d we got is as 6d plus 6, right? So its derivative is 6d and 6 is 0. So the final derivative we get is 6. So now there is no chance of getting the value of d as 0 since there is no d term left. So the value of yp2 is 6 into x. Now it is x cube. We have taken one more time derivative, right? So e power x divided by whatever we got, that we have to write 6. So the 6 gets cancelled. So the final value of yp2 which we get is x cube into e power minus x. See, like this we need to solve this problem. So now the problem is not done yet. We need to find yp3 now. That is 1 by f of d d cube plus 3d square plus 3d plus 1 into 7, right? So 7 into e power 0x, we can write it like this also. So here the value of a is 0, so 7 by e power 0x, so e power 0 is 1, so 7 into 1, 0 cube plus 3 into 0 square plus 3 into 0 plus 1. So this whole term is 0, only 1 remains, so the value of yp3 is 7 by 1, 7. So the total yp, we get it as yp1 plus yp2 plus yp3. So yp is equal to, what we got yp? The value of yp1 is 5 e to the power 2x by 27 plus the value of yp2 here is x cube into e power minus x plus yp3 is 7. So this is your particular integral final. So now we are going to write the general solution. So now general solution is given by y is equal to yc plus yp. Therefore y is equal to yc, what we have got, c1 plus c2x plus c3x square into e power minus x, right, plus the yp particular integral we got it as 5 e power 2x by 27 plus x cube into e power minus x plus 7. So this is the completion of this huge problem. It's an easy problem actually, so we need to know the steps and all very carefully. Okay, yeah, so that's all for this session. So this completes this topic of type 1 problems. So in the next session I am going to start with the type 2 kind of problems. Okay, I am going to explain that and I am going to start with the concept. That's all. Thank you.